we're going to look at angles in circles. So the first question you need to ask yourself when you see any types of these questions is, what do you see? What kind of lines are there? What angles can you work out? Are there triangles? So what shapes are there? What kind of triangles are there? Are there any parallel lines? Any tangents? Any chords? Things like that. That's what we're looking for. Now, if you're uncertain what some of those things are, we'll look at it on the next page. But that is what you need to do, is just think, what do you see? Because for any one of these questions, there's not a set format to work them out. So, first of all, we need to remember the parts of a circle. So, the key thing that we'll be using with this, radius, diameter, a chord. We'll be looking at chords as well. Okay. There's also an arc, a sector, which we should be familiar with. Segment is this orange part right here, and the circumference is the whole distance around the circle. So you need to be familiar with these. The new ones might be the chord for us to look at. So now, thinking about what we've just talked about, think now, what do you see? You can pause the video to have a moment to look at it. So, we'll come back to these questions. This is an exam question that you're going to end up working on. However, I just wanted you to see what you can find. Alright, now here are the circle facts that we need to know. First of all, the angles in a semicircle, or the angle in a semicircle, is always 90 degrees. So if I have a circle, and I'm going to take half of that circle, so my diameter, I'm going to cut it across, and the angle that's coming off of my diameter here to the circumference, so the angle that's coming off the diameter, so both sides of that diameter, and it touches the circumference in half of my circle, so in my semicircle, it's always 90 degrees. So that angle there is 90 degrees. That will be a very useful fact. And again, here's just another example. So there's my diameter, coming off my diameter, over to the side now. That angle that is touching the circumference, or the edge of the circle, is 90 degrees. Then a third example. So those are all 90 degrees. That is something to look for in an example, or in a question, sorry, that will be really useful. And similarly on the other side, this one has two angles in a semicircle here. So they're just touching on opposite sides there. Right, tangents to a circle. Now this one comes up quite a lot, and it's very useful. So, there are three ways that a straight line can intersect a circle. So let's look at those. First one is the diameter. There's also a chord. Then we have a tangent. Okay, this is, here we have the diameter is going straight through the center. The chord touches touches the circumference twice, or crosses the circumference twice, but it doesn't go through the center. And the tangent touches the circle once. So, when we're looking at tangents, the tangent is a line that touches the circle at one point only. So it will be on the outside of the circle. So this here is not a tangent. Neither of those are tangents. However, this is a tangent. Okay? So cutting 2 points, that's not a tangent. Not touching a circle, that's not a tangent. It touches at one point. So those are some examples of tangents. So the rule with this is a tangent and a radius. So my next rule, or circle theorem, as they like to call them, is a tangent is perpendicular to the center of a circle at the point of contact. Meaning, we have a circle, and I have a tangent, and my radius, which comes from the center to the tangent, Well, they meet at 90 degrees. So a radius and a tangent meets at 90 degrees. That is my key point. So my radius and my tangent meets at 90 degrees. Again, radius and tangent meet at 90 degrees. Now again, this is very common and it will show up, and you just have to identify that that's 90 degrees. And then it'll help you find the other angles. And then there's a third one we're going to look at. Not as common, but it could show up. And this is going to be two different tangents drawn to a circle from the same point are equal in length. So let's take a look at what that means. So if I have two tangents, and again, this should extend. Okay, so these tangents will be extended here as well. Okay. So we have the radius meets these tangents here at 90 degrees, so we know that fact. But because we have these two tangents meeting at one point, this is telling us that these two lengths are equal. Similarly on this one, here I have two tangents meeting at one point. So this tells me that these two lengths are equal. Here's a question for you to look at. We want to find the two angles S and T. So pause the video and just write down what you see. Okay, so when we're looking here, we will notice that we have a triangle, but the type of triangle we have is very important. So here, from the center to the edge, we know that's a radius, and we actually have 3 of those. So what that tells me is that all those lines are equal. And that's really important for this triangle, because this triangle, therefore, is an isosceles triangle, because I have 2 sides that are the same. And if those 2 sides are the same, then these 2 bottom angles are the same. So these are both equal to T. And that is something to look out for in these questions. The triangles, if they are isosceles, will be really helpful. So the first thing I'm going to do is I'm going to work out angle S. Now you'll see that angle S is going to be 180 degrees because it's on a straight line. So S plus 72 is 180. Subtract 72 from 180 and you get 108. So S is 108 degrees. Now that we know that, and we also know that this is an isosceles triangle, well, like I just said, all this information, we can do 180 minus 108 and we get 72. Now both of these at the bottom are equal to 72. To get one of them, we're going to half it, and so each of these 2 bottom angles of T are 36 degrees. Now in summary, all of this is here. These are the 3 theorems that we've looked at. So angles in a semicircle are 90 degrees. The tangent is perpendicular to the radius, and that means a tangent and a radius meet in 90 degrees. Tangents from a point are equal. And lastly, if we wanted to add it in, we have this other circle, a poorly drawn circle, and if we have 2 radii, it's very hard to draw this freehand, they make an isosceles triangle. And that therefore means these 2 angles at the bottom are equal.